Right now, as you watch this video, you're moving through time at exactly 1 second per second. It feels ordinary because you've never known anything else. But what if time isn't as fixed as it seems? What if the future could be reached faster than expected? What if the past isn't truly gone? From Einstein's revolutionary discoveries to theories involving wormholes, black holes, and parallel universes, the science of time travel challenges everything we think we know about reality. And the truth may be even stranger than fiction. Take the famous grandfather paradox. Imagine you travel back in time and meet your grandfather when he is a young boy. If you somehow prevent him from growing up and having children, then your father would never be born. If your father were never born, you would never exist. But if you never existed, how could you have traveled back in time in the first place? That would mean your grandfather was never prevented from having children, which means you would be born and would eventually travel back in time. This creates a logical contradiction with no clear solution. Scientists have proposed several possibilities. The past cannot be changed. Any attempt to change history somehow becomes part of history. Changing the past creates a new timeline or alternate universe. Currently, there's no evidence that backward time travel is possible. It remains one of the most controversial ideas in physics, and there is still no accepted explanation for how paradoxes like this could be resolved. So, does that mean time travel is impossible? Not exactly. While traveling to the past remains highly speculative, traveling into the future is supported by modern physics. According to Einstein's theory of relativity, future time travel is not only possible but has already been demonstrated through time dilation. There are several concepts associated with traveling into the future. Some are supported by real science, while others are theoretical ideas connected to time travel. Time dilation is the slowing of time as measured by one observer compared with another, depending on their relative motion or the strength of the gravitational field around them. Time dilation is a real phenomenon predicted by Einstein's theory of relativity. It occurs when an object moves at extremely high speeds or experiences strong gravity. This means time does not pass at the same rate for everyone. For a person traveling close to the speed of light, time would pass more slowly compared to someone on Earth. A famous example is the twin paradox. One identical twin remains on Earth while the other travels through space at a speed close to the speed of light. When the traveling twin returns, they're younger than the twin who stayed on Earth. This happens because time passed more slowly for the traveling twin during the journey. This effect is not just theoretical. It has been confirmed using precise atomic clocks on aircraft, satellites, and high-speed particles. GPS satellites must even account for time dilation to maintain accurate positioning. So this is our first scientifically proven way of traveling into the future. Now let's move on to an even more extreme example of time dilation. Gravitational time dilation, near black holes. In theory, a black hole could act as a one-way time machine into the future. According to Einstein's theory of relativity, gravity slows down time. The stronger the gravity, the slower time passes. Black holes contain the strongest gravitational fields known in the universe. If you could safely orbit near a black hole without falling in, time would pass much more slowly for you than for people far away. The movie Interstellar used this idea. On Miller's planet, which orbits close to the supermassive black hole Gargantua, 1 hour corresponds to several years on Earth. The exact numbers are fictional, but the underlying concept is based on real physics. Can a black hole send you into the past? There is currently no evidence that it can. Some speculative theories involving wormholes suggest such possibilities, but none have been proven. Before we continue, it's important to make a distinction. The next three concepts are not proven methods of time travel. Unlike time dilation, which has been experimentally confirmed, these ideas are theoretical or speculative concepts that are often discussed in connection with time travel. Now let's move into ideas that remain entirely theoretical. A wormhole is a hypothetical tunnel through space-time that could connect two distant locations in the universe. The concept comes from solutions to Einstein's equations of general relativity. In 1935, Einstein and physicist Nathan-Rosen described what is now known as an Einstein-Rosen bridge. Some theoretical models suggest that if one end of a wormhole experienced extreme time dilation, it might connect different points in time as well as space. However, no wormhole has ever been observed. We do not know whether they exist, whether they can remain stable, or whether anything could safely travel through them. Cryogenic preservation, often called cryonics, is not actually time travel. Instead, it is an attempt to preserve a person until future technology becomes advanced enough to revive them. After legal death, the body is cooled to extremely low temperatures and stored in liquid nitrogen. The hope is that future medical advances may be able to repair the damage that caused death and restore the person to life. In a sense, this could allow someone to skip decades or centuries and wake up in the future. However, no human has ever been successfully revived after cryonic preservation. Scientists do not know whether memories, consciousness, or brain structures could survive the process. The preservation is real. The future revival remains entirely unproven. Multiverse travel is the hypothetical idea of moving from our universe to another universe. The multiverse hypothesis suggests that our universe may be just one of many universes. Some theories propose parallel universes where different versions of history unfolded in different ways. For example, there might be another universe where you chose a completely different career path or where major historical events occurred differently. Some speculative theories suggest that wormholes, quantum effects, or higher dimensional physics could provide a way to reach another universe. However, there is currently no evidence that other universes exist, and there is no known method of traveling between them. Multiverse travel remains one of the most speculative ideas in modern physics. So, is time travel possible? The answer depends on what kind of time travel you're talking about.
Traveling into the future is supported by modern physics. Time dilation has been experimentally verified, and according to Einstein's theory of relativity, time can pass at different rates depending on speed and gravity. Traveling into the past is a completely different matter. From the grandfather paradox to questions about causality, backward time travel creates problems that modern physics has not yet solved. Ideas such as wormholes and multiverse travel remain theoretical, while cryogenic preservation is not actually time travel, but an attempt to reach the future through preservation. Time dilation remains the only scientifically verified mechanism that can effectively allow travel into the future. What makes time travel so fascinating is that it sits at the boundary between established science and imagination. Some aspects have already been proven, while others remain among the greatest mysteries in physics. As our understanding of the universe grows, we may discover possibilities that seem impossible today. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more videos exploring the mysteries of space, physics, and the universe. And I want to hear from you. If you had the chance to travel through time, would you visit the past or the future? Let me know in the comments below. Thanks for watching, and I'll see you in the next video.